Donald Shell published the first version of this sort in 1959. The running time of shell sort is heavily dependent on the gap sequence it uses. For many practical variants, determining their time complexity remains an open problem.
Shell sort, also known as Shell's method, is mainly a variation of insertion. In insertion, we move elements only one position ahead. When an element has to be moved far away, many movements are involved. The idea of shell sort is to allow exchange of far items. In shell sort, we make the array H sorted for a large value of H. We keep reducing the value of H until it becomes 1. An array is said to be H sorted if all sublists of every H element is sorted. By starting with far apart element, it can move some out-of-place elements into position faster than a simple nearest neighbor exchange.
These numbers are the elements of an array named A. Then A1 to A9 are the index inside of an array. 41 is the first subset. Then this gap between the first subsets are called interval. So our subsets is 41, 5, and 32. Then it will be sorted as lowest to highest.
After shortening each of the subset in the first iteration, the list would look like this. We can note that although we don't have short lists yet, the elements are now close to desired position. And finally, we need to do the one more short with the increment of 1, and it's actually basic. Insert short, the number of shifts operation that we need to perform to sort a list is now smaller than it would be the case if we don't do the first iteration.
Shell sort. Our gap now is 1, and the program will check the value of the first number and the second number. If the first number is less than to the second number, the program will proceed. And if the first number is greater than to the second number, the program will swap the value of it. And after that, the number being swapped, the program will check again the left side of the array if the two numbers are greater than or less than.
So as you can see, the program determined that all numbers are sorted properly from lowest to highest. The program will check gap by gap to sort the value, and shell sort uses insertion sort to sort the values of the array. And always remember, if the first number is greater than to the second number, the program will swap the value of it.
First, let us type a class first. Public class shell sort. Then we go to the main method and we put the array list. In ARR, open and close bracket and put the number inside the statement. 41, 15, 82, 5, 65, 19, 32, 43, and 8. After we put the list of array, we print it out before it's sorted. We will call the array print method to see the values inside the array, then create a new cell sort object. Cell sort OB was new cell sort. And we will call the sort method for our program to have a function ob.sortarr. And let's print the new array value after sorting the array. Now we will do the print array method. Static void print array parameter int arr. We need the method. We will use for loop so that we can print it vertically. First, we will get the number of the value inside the array. Int n equals arr.length. And we will now use for loop. For I equals 0, semicolon, I less than n, semicolon, I plus plus, then print it out. System.out.print ARR I.
We'll be discussing about the looping for this part of code. So inside this method, this int n is equals to 9. So the first for looping is gap is equals to 9 over 3, which is equals to 3. So is 3 greater than to 0, so true. So inside it is the second for looping. So int I is equals to 3. So is 3 less than to 9, so true. So int temp is equals to array index 3, which is 5. So j is equals to 3 is 3 greater than or equals to 3, so true. In logical end our index 0, which is 41, is 41 greater than 2, 5, so that is true. So r index 3 is now equals to r index 0, so the value of r index 3 is now 41.
After assigning the value of ARR index j minus gap to ARR index j, which transfers the value of 41 to array index 3, we will now do the operation on the right side of the loop. So j minus equals to gap, that is 0. So going back to the condition, is j greater than equals to gap? The value of gap now is 3, so that is false. We will now exit the loop and go to ARR index j equals to temp, which means that the value of array index 0 is now 5. Okay, now please look at these tables. This shows the changes that happens to the values of array when the program runs completely. On the right side is the actual output that we will get after running this program. If you would like to have a better look, you can pause this video and carefully examine the table. Okay then, so how do we came up with these tables? So we have modified the code a bit to show the changes generated by every line of the code. So this illustration will show the changes in values of the array, variables, and the evaluation of the conditions and expressions. So first, let us look on the output. So first, we have displayed the initial value inside the array. Then we have assigned the array length to variable n and determine the gap using n divided by 3. We have divided to 3 because we're using a gap of 3 and 1. So we use the 3 as our initial value for division. So then we have set the value of j and I. After that is the condition wherein we are comparing the value using the gap of 3. With this, if the condition is true, then it means that the value on the left side that is stored in the temp is higher than the right side, so we will transfer its value to the farther right. Now, we will update the value of j. This is to assign the temp value to the previous index. So, if the value of the condition, if the condition is resulted into false, then the temp will be assigned to the index in ARR index j equals to temp. So, that what we will get if the value is value of the condition is false. So that's it. So we will continue to run this line of codes until we have finished to run the program. So we have prepared the complete output for this. Again, you can pause the video and you can go back to carefully examine the tables that is being shown. So that's it. So that is shell sort, and this is group 13, and thank you for listening and have a nice day.